The next question says, which equation represents a parabola with a focus at 0, -1 and a directrix at y equals 1? So my focus is at 0, -1, which means my x value is 0, my y value is -1. So my focus is 0, -1, which is right down here. So I'm going to make F. My directrix is at y equals 1. Y equals is a horizontal line, and there we go. That's y equals 1, and that's my directrix. Now, I need to find my vertex in order to find the equation of my parabola. My vertex lives perfectly halfway between the directrix and the focus, and this one's pretty easy. It's right at the origin, at 0, 0, meaning that my vertex is 0, 0. Now, because this parabola is downward, I'm going to be using the equation x minus h squared equals negative 4a y minus k. H and k are the vertex. So it's going to be x minus 0 squared equals negative 4. The a value is going to be 1 in this case because the distance from here to here is 1, and there to there is also 1. So that's 1, and then y minus 0 as well. Cleaning this up, x minus 0 is just x, and then square it. Negative 4 times 1 is negative 4, and y minus 0 is just y. So if you look at this, your answer is not in y equals form. If you look at the choices, it's simply choice 2. The equation 3x squared plus 12x plus 3y squared plus 66y equals 24 is equivalent to. Now, if you look at all the choices, they all have the same left side. So what I'm going to do is I'm going to expand them. X plus 2, x plus 2, plus 3, y plus 11, y plus 11 equals, we know 24 has to be there because it's here. Now there are two ways to do this problem. I'm going to do it this way first, and then I will show you the other way to do it. So what you're going to do is you're going to box method this inside piece. So you would get x squared plus 4x plus 4 if you box method that. Plus 3y squared plus 22y plus 121 equals 24. Now, you would do box method to get that result. And if you look at the original, in the problem, you should notice that there's a 3 next to the x squared and a 12 next to the x. This makes sense because I have a 3 outside here, and if I was to distribute the 3, I would get 3x squared plus 12x plus 12. So this 12 is what's been added. So because that's what's been added, this 12, I'm going to add that 12 to the 24. I'm going to do the same thing here. If I distribute this in, I have 3y squared plus 66y plus 362. That 363. 3 times 121 is 363. That 363 is what is added on this side, so I'm going to add that to here. If you add up the right side, 24 plus 12 plus 363, you'll end up with 399, which is your final answer of choice 3. Now, the second way to do this problem is to complete the square. The reason why you can complete the square with this is if you look at the choices, you should see that they have these x plus 2 and y plus 11 all squared. So like theoretically, this is 3x plus 2 times x plus 2 plus 3 y plus 11 times y plus 11. And we know 24 is on this side for sure, but if you notice, if you multiplied this out, you'd get the trinomial like how we got it down here. So there is something that needs to be added over here. What they did was they took this, pulled out a GCF from the x's, so you get x squared plus 4x. I'm going to leave a blank there, and then they pull a GCF out for the y's. They only took out the number, though. Okay. We're going to put blanks in here because that's the whole idea of completing the square, 24, and then we'll have 2 blanks over here. So to get that trinomial that's the same, well, binomial and binomial at the same, you need a trinomial, a perfect square trinomial. To do that, you complete the square. So 4 divided by 2, you take your b value and then square it. 4 divided by 2 is 2, square that, you get 4. So I'm going to add 4 to both sides. Now, right there is a mistake because it's not just 4 that gets added to this side. It's whatever you distribute in with the 3. So really what I'm adding here is a 12. Okay, and I'm going to also take the b term, divide it by 2, and square it. That'll get you 11 squared, which is 121. You're not adding 121, but a 363 over here. If you add these all up, you'll also get your answer of 399. This question can be done in your calculator. All you have to do is press the button second, then press the button matrix. It's underneath the math button. Then go over to math, go to R, R, E, F. You're going to see that on your screen. Then you're going to press alpha, zoom. Make sure there are 3 rows and 4 columns. What you're going to do is you're only going to put in the coefficients. Okay, so your calculator screen should look like this. -5, 3, 6, and 4. -3, 1, 5, -5. And -4, 2, 1, and 13. Press enter, you should get this on your screen. A bunch of zeros and ones. This is telling you the x, y, and z values to be -2, -4, and -3. Now they want one solution. This isn't a solution. This is a solution. And this was supposed to be +4, that's why I paused. So that's not a solution, and that's not a solution because it's supposed to be -2. So the answer is choice 3. The next question says the directrix of a parabola, 8 parentheses x minus 3 equals y plus 1 squared has the equation x equals 1. Find the coordinates of the focus of the parabola. Now, they tell you the directrix is x equals 1. So that means that on my graph, I have at 1 a vertical line at x equals 1. This also tells me that my parabola is opening up to the left or to the right, and I'm going to figure that out with the equation they gave me. Now, what's annoying about the equation they gave me is that it's in the wrong order, so what I'm going to do is just flip around the sides, making y plus 1 squared on the left and the 8x minus 3 on the right. This formula is y minus k squared equals positive 4a x minus h. This tells me my parabola is opening up to the right. Okay, my vertex is going to be 3, positive 3, comma negative 1. Remember, it's opposite signs. This is the x coordinate because it's next to the x, and this is the y coordinate because it's next to the y. So I'm going to plot -3, positive 3. This is 1, 2, 3, and then -1. This is my vertex. I know it's opening up to the right. Now there's 2 ways to get your focus. The first way is to realize that this distance is 2, so your distance will be 2 on the other side of the vertex, giving your focus the point of 1, 2, 3, 4, 5, -1. So my focus is at 5, -1. But you could also get your a value from the 8 here. The 8 would be equal to 4a, and divide by 4, so equal to 4a. If you divide by 4, you get that a value as well as 2. This question says solve the system algebraically and illustrate graphically. The first thing I'm going to do is do this graphically. This is a circle right here with a center of 0, 0. I know that because there's nothing next to the x and the y, and the x and y's are both squared, so that has to be a circle. And my radius, if I take the square root of 9, will be 3. So what I'm going to do first is plot the circle. So center 0, 0. I'm going to count 3 to the right, 3 up, 3 to the left, and 3 down, and make a circle to the best of my abilities. Okay, and now I'm going to plot my line. This is mx plus b. So my y-intercept is -3, and my slope is 1 over 1. So I'm going to go to negative 3 and plot that point, and then go up 1 over 1, up 1 over 1, over 1, up 1 over 1. I could do one more down here, and now I have my line. So I can see already that my solutions will be 0, negative 3, and 3, 0. So now all I have to do is do this algebraically. So what I'm going to do is I'm going to use substitution. That's the only way you currently solve a line in a circle problem. I'm going to put this y equals into where I see y. So I'm going to keep the x squared that's already there, and then I'm going to substitute in the x squared, x minus 3 squared equals 9. I'm going to have to do box method here because it's a binomial squared. So I'll get x squared minus 3x, and 9. Then I'm going to have x squared plus x squared minus 6x plus 9 equals 9. I'm going to combine like terms on the left side, which gets me 2x squared minus 6x plus 9 equals 9. I'll get the set equal to 0 because x squared likes to be equal to 0. Those will cancel. And I'll get 2x squared minus 6x equals 0. Now to solve, I'm going to have to factor. And the proper way to factor this is to use GCF. And the GCF is 2x. It can go into both of these. I'll pull that out, and I'll be left with x minus 3. I'll set both sides equal to 0, divide by 2. So I'll end up getting x equals 0 on this side, and x equals 3 over here because you add 3 over. Now, you're going to have 0 comma something and 3 comma something. You're going to find that comma something by using the equation all the way up here, that y equals x minus 3. I'm going to substitute in my x values, so I'll have x minus 3. I'm going to put in 0, so that'll get me negative 3 for my y value here, and then I'll do x minus 3 here, and I'll do 3 minus 3, and that's 0. And what's nice is now we know these are right because we graphed them over here. The next question says solve algebraically, so the first thing I'm going to do is subtract my 1 over because my radical needs to be by itself before I can go on to the squaring step. So I'm going to go ahead and I'm going to square both sides. This will cancel out, and I'll get 12x plus 1 equals, I'm going to have to do box method over here because it's a binomial squared. And I'll get 9x squared minus 3x, and 1. Okay. So I'm going to have 12x plus 1 equals 9x squared minus 6x plus 1. So again, like I said in the last problem, x squared likes to equal to 0. So I'm going to subtract the 12x over here and subtract the 1. What's nice is that this becomes 0, and this also cancel out on the right side. The 1s cancel out. And I'll end up with minus 18x. This is another scenario where I have GCF because I have a binomial that can divide by 9x. And I'll be left with 9x and x minus 2. And I'm going to set them both equal to 0. I'm going to divide by 9 over here so I can get x equal to 0. And then I'll add the 2 over here, and I'll get x equals 2. Now the last thing you have to do is check your answers because you could get an extraneous solution. And when we do that, we reject it. So one way to do it is to plug in the 0 and the 2 into the original. The other way to do it is to plug in the left side of the original equation into y1 and this into y2, and then check the table. And when you do that, you'll find out that 0 does not work. It gets rejected. But to prove it to you, 12 times 0 plus 1 should equal 3 times 0. This side should be 0 then. You'd have 0 plus 1 plus 1. That would be the square root of 1 plus 1. That gets you 1 plus 1. That's 2, which does not equal 0. And to check it on this side, you would plug in 2. So 12 times 2 plus 1 equals 3 times 2. This side will get you 6. 12 times 2 is 24, plus 1 on the outside. So the square root of 25 plus 1, that's 5 plus 1, which does equal 6. So that does work. This guy is a division problem. You can do synthetic division or you can do long division. I prefer synthetic because it's easier and quicker. The first step to synthetic is setting the bottom equal to 0. That number now goes into the box. Now what you do is you take your coefficients, 3. Be careful though, there's a missing 0x squared here, so you're going to put 0 in its place. And then 15 and negative 35. I'm going to drop down my 3. Always do that. And then I'm going to multiply 2 times 3 to get this number, which is 6. Then I'll add. You always add. That gets you 6. And then I'll do 2 times 6 to get this number, which is 18. 2 times 6 is 12. I'm sorry. That was silly. Okay. 2 times 6 is 12, and then you'll add to get 27. And you multiply again. 2 times 27, which gets you 54. And you'll add and get 19. That's your remainder. So now what you're going to do is you're going to go down by a power. This starts with an x cubed, so you're going to go down to x squared, x, and then number, and then your remainder. So your answer will be 3x squared plus 6x plus 27 plus 19. Put your remainder over your divisor. Now a good way to check yourself is to actually plug in 2 into the original. And if you plug in 2 into the original, this is a nice check because it's using the remainder theorem. And the remainder theorem states when you plug in that number, you get the remainder, which is 19. So that's how I checked myself. This guy here, the first thing I'm going to do here is distribute the z cubed, well, the cubed into both. I can do that because there's nothing in between the z and the I. This guy, though, needs box method because there's an addition sign between. That's the difference. You cannot distribute this squared in this case. So if I multiply this, I will get z squared, 3zi, 3zi again, and 9i squared. So now I have z squared plus 6zi plus 9i squared. And then what I can do is I can distribute this in to that. So I'm going to end up getting, that should be cubed, sorry. I'm going to end up getting z to the 5th, I to the 3rd. And then I will have 6z to the 4th, I to the 4th. And then plus 9z to the 3rd, I to the 5th. And what you can do is plug in these powers of I into your calculator. I to the 3rd is negative I. Plus 6z to the 4th, I to the 4th is 1. And I to the 5th, believe is negative 1, but I will check. Oh, it's just I. Okay, so now I just will reduce this. I'll bring this negative to the front, negative z to the 5th I, plus 6z to the 4th, because that 1 just goes away, and then plus 9z to the 3rd I. This is only one way of doing it. You could do it in different steps, but the ultimate thing you need to do is get this answer. Now, a good way to check yourself is to actually plug this in to your calculator, like the regular screen, but make the z's x's, and then plug in the original into your calculator screen, this guy here, and you should get the same number on the calculator screen. This question asks you to factor. So the first one is dots. It's dots because I can take the square root of the thing of both pieces and get 3x minus 10y. And then I would do 3x plus 10y. Done. This guy here, I can take a GCF out of 3. Make sure you keep that GCF on the outside. So I get x squared minus x minus 6. And then I can do AM minus plus. Factors of 6 that add to negative 1 are 3 and 2. And then this guy is cubes. You see all the cubes? So you should take the cube root, kind of similar to dots. You get 4a minus z. That's the first parenthesis. Then you have the second parenthesis. Remember, we write the word soap. Same, so that's negative. Opposite, always positive. I'm going to square multiply square to get these numbers. So I get 16a squared, and then 4az, and then z squared. This guy, they want you to graph this. Basically, they want you to change g, and we can change g by going left 1 and down 2. Okay, so all I have to do is move each point left 1, down 2. So left 1, down 2, left 1, down 2, left 1, down 2, left 1, down 2, and left 1, down 2, and there we go. Now this one says using any method. So you do one of two things. You can either do it algebraically or graphically. If you were to do it graphically, you got to set them both equal to y. So the first one will become y equals 2x squared minus 4x minus 1. And the second one will be y equals negative x plus 1. So what you're going to do, if you do it graphically, is plug it into the calculator in y1 and y2. Make your picture on the paper to get full credit. Just want to be exact, just has to kind of look like your calculator. It looks like this, sort of. And then there's the line that goes through it like this. And to find the intersection points, you're going to press second, not second, second calc, number 5, intersect. And then you're going to press enter 3 times when you get over the intersections. You're going to get 2 intersection points, one here and one here. This one is negative 5, comma, 1.5, and this one is 2, negative 1. That is the easiest way to get the answers. So I'm only going to do this in the video. But if you want to know how to do it algebraically, come to extra help. All you have to do is set them equal to each other and solve. I have it on the key online as well. This guy is a quadratic because there's an x squared there. It says express the answer in simplest a plus bi form. This tells me there's going to be an I in my answer, which probably means I'm going to use the quadratic formula. This is like a hint. You could also complete the square if you really wanted to, but the quadratic formula is given to you. So the first thing you should do is subtract over that 9, so you got it equal to 0, and that'll get you 4. And then a is 5, b is negative 2, and c is 4. Okay, and then what you're going to do is you're going to use the quadratic formula it's given to you. Okay, and you're going to plug in. So it's going to be x equals negative. There's a negative in there. And then I need to fill that in. Okay, so negative 2 is going to go there. And then b squared, make sure you put it in parentheses. Minus 4. A is 5, C is 4 again, all over 2A, which is 5. So I have x equals positive 2 now, over 10, plus or minus. All I'm going to do is plug in the inside, not the radical, into my calculator, and I'll end up getting negative 76. And that's where the I is going to come in, because there's that negative under the square root. And I'll split this up into 4 and 19, because I need to reduce the radical. So I'm going to have 2 plus or minus I, because of the negative, comes out as I. The square root of 4 is at 2, so that 2 is going to go right in front of that I, and the square root of 19 goes here. Now split this up, which means you're going to do 2 over 10 plus or minus 2i radical 19 over 10. Now listen, you have to make sure you split it up like this because they start to talk about this a plus bi form up here. If it's not separated, this is incorrect. You have to write it as 1/5 plus or minus 2i. Well, not 2i because it simplifies actually also to 1/5 again. So that means I radical 19 over 5, and that's your answer. This question asks how many solutions exist for this equation. What you should do is put this into y1 and this into y2, and then graph. Okay. So you're going to have a graph that looks a little weird. It has this up here, it has this guy here, and this guy here. And then you see this upside down absolute value thing going on. So let me try my best to make it. I think there's an intersection here, 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 and here. So it's going to look something like this. Okay. So the answer would be 1, 2, 3, 4 intersection points. The next part says find the x values to the nearest tenth. All you have to do is do the second trace intersect command on your calculator and bring the blinky dot over the intersections and press it 3 times. And you're going to get the first one to be x equals negative 0.5 to the nearest tenth. The third one, so this is negative 0.5 down here. The third one is 0.9. This one's 2.4. This is negative 1.4. I think I actually have them backwards. Hold on. I know I have the answers, but I feel like I'm not putting them in the right spots. This guy is negative 1.4 because he's down here. This guy is negative 0.5. This guy is 0.9, and this guy's probably 2.4. But anyways, these are your answers for this. And that's that. Study up. I'll see you guys soon. Bye.